Hi, my name is Ricardo Bindi. My supervisor is Milton Sabino Canteiras. I work at the University of São Paulo at the Institute of Biomedical Science. And, and this work is the effects of cuneiform nucleus on fear and hunting. Well, we saw that the cuneiform nucleus is involved in defensive behavior and is a sympathocitatory area by the studies that have been previously published. And studies with CFOS have shown an increase in activity in non-noxious and noxious stimulus and cat exposure. Moreover, this region is deeply connected with central regions in the defensive circuitry. And considering those pieces of evidence, we had the drive to perform more investigation in this region. The main objective of the study is to investigate the role of the cuneiform nucleus in encoding active and passive fear coping strategies, and we developed a series of behavioral paradigms to study that. We explored the projections of the investigated region. We also elucidated the impact of inhibition and optogenetic stimulation of this nucleus in hunting and defensive behavior, and we investigated the electrophysiological activity of this region in different environments and behaviors. Projections were made using immunohistochemistry, and activation were made using multimodal and optogenetic. Stimulation were made using virus with channel rhodopsin, and the electrophysiological recordings were made in two different phases: an habituation, cat exposure, and context. So we can see the afferent outputs of the cuneiform nucleus, and it clearly projects two important hypothalamic nuclei involved in defensive behavior, and it also receives information in afferent inputs with different hypothalamic nuclei also. This region also sends and receives information from mesencephalic regions that are known to be involved in defensive behavior, mainly pagans and superior colliculus. In the previous video, you can clearly see the drastic behavioral change in the animal. The rat clearly changes the exploration and eating behavior to when it's off, to freezing and flight behavior when the optogenetic stimulation is on. During the inhibition with multimodal, you can see that the only change that is relevant is during cat exposure with multimodal, and there is significant change to diminish freezing and increase risk assessment. So the inactivation of this nucleus is involved in reducing the defensive behavior. The electrophysiological recording shows that some cells have lower activity during cat and post-cat exposure, and increased activity during new environment, and also decreased activity in the context. And some cells increase, and you can see those two patterns. And when you compare the specific behavior changes, you can see that the environment is far more predictive of the activity when compared to the specific behaviors. So the conclusion is that the cuneiform nucleus is situated in a privileged position. Activation of the nucleus promotes defensive behavior. Inactivation of this nucleus during cat exposure reduces freezing and increases risk assessment, and the cuneiform nucleus activity is highly related to environmental conditions and to a lesser degree to specific fear-related behaviors.